All right, let's talk about the base angles theorem. The base angles theorem says that if two sides of a triangle are congruent, then the angles opposite them are also congruent. So this is true for isosceles triangles because in isosceles triangles, two sides are congruent. So if you look over here at this triangle on the right, AB and AC are marked as congruent, which means since there are two sides that are congruent, there are two angles that are congruent. And the angles that are congruent are across from the sides that are congruent. So the angle across from side AB is C, and the angle across from side AC is B. So angles B and C are congruent. The converse of that is also true. If two angles in a triangle are congruent, then that means that two sides are congruent. So in this triangle down below, because angle B is congruent to angle C, that means that the side opposite of B is congruent to the side opposite of C. When we're talking about isosceles triangles, we call the two sides that are congruent to each other the legs of the triangle. And then the side that is not congruent to the other two is called the base. So the angles that are congruent to each other are sometimes referred to as the base angles. And then the one angle that is not congruent is referred to as the vertex angle. So if you hear me use those words, that's kind of the definition of each one of those parts of an isosceles triangle. All right, so in triangle DEF, DE is congruent to DF. It's talking about two sides. So because two sides are congruent, two angles are congruent. And the two angles that are congruent, otherwise known as the base angles, would be angle F, because that's the angle across from side DE, and angle E, because that's the angle across from side DF. Down below, if HG is congruent to HK, so HG is congruent to HK. So we're talking about this little triangle on the left, not anything in the big picture, just this little triangle. So if those two sides of the little triangle are congruent, then that means angle G is congruent to angle K. But we can't just call that angle K because K is the vertex of multiple angles there, so we could call it HKG. All right, let me erase that so we can do the second part. If angle KHJ is congruent to angle KJH, then what two sides would be congruent? So two angles are congruent means that two sides are congruent. The side across from the H vertex is KJ, and the side across from the J, angle J, is HK. So a corollary to the base angles theorem, corollary means it follows from the base angles theorem. So base angles theorem says if two sides are congruent, two angles in the triangle are congruent. So what that follows from then is that if three sides of the triangle are congruent, then that means that three angles in the triangle are congruent. Or another way of wording that is if the triangle is equilateral, as in all the sides are congruent, then it is equiangular, which means all the angles are congruent. And the converse of that is also true. If all the angles are congruent, then that means all the sides are congruent. If it's equiangular, then it's equilateral. So in this first picture down at the bottom in triangle PQR, it says find the measures of angle P, Q, and R, but none of the angles are labeled right now. What we do know about the triangle is that it's equilateral because all of the sides are marked as congruent. So since all of the sides are marked as congruent, that means all of the angles are congruent. And because all the angles in a triangle need to add up to 180 degrees, if all of them are congruent, we would take 180 divided by 3, and that means each angle must be 60 degrees. So if a triangle is equilateral, then each angle is 60 degrees because they're all congruent. And so in the second picture, we're practicing using the converse here. All of the angles are marked as congruent. And if all of the angles are marked as congruent, then that means all of the sides are congruent. So if TU is 5, so is SU, and so is ST. So let's practice that with some pictures. So in this first picture, let's look at triangle KNL. So triangle KNL has all the angles marked as congruent. So if all the angles are 60, if they're all congruent, that means all these sides are congruent, which means if KL is 4, that means KN is 4, so Y equals 4. It also means that NL equals 4. All those sides are 4. And if NL equals 4, that helps us find what X is, because this triangle on the right, triangle NLM, is isosceles. We know it's isosceles because two angles are marked as congruent. Angle M and this angle over here with a vertex of N. So because two of the angles are congruent, that means two of the sides are congruent. So 4 is going to be equal to X plus 1, which means that X needs to be 3. Over in the second picture, let's look at the triangle that has the X in it first. All of the sides are marked as congruent. And since all of the sides are marked as congruent, all of the angles are congruent, which means all of our angles are 60 degrees. And then this big angle over here on the left is marked as a 90-degree right angle or right angle. And so if part of the angle is 60 degrees, that means the other part of the angle must be 30 degrees. And because this triangle on the left with the Y in it is isosceles, see how two sides are marked? It's isosceles. If this base angle is 30 degrees, that means this base angle is 30 degrees also. And because all three angles of a triangle need to add up to 180, that means angle Y plus the two base angles that are 30 degrees each need to add up to 180, which makes Y equal to 120. Let's get some more practice. So the triangle, let's look at the shape on the left. So in the shape on the left, the triangle on the left is isosceles. Two sides are marked as congruent. And because those two sides are marked as congruent, that means the base angles are congruent. So we have 72 degrees and 72 degrees. And then notice this angle is marked as congruent to this angle, which means that this angle up here is also 72 degrees, since they're marked as congruent. The triangle on the right is also isosceles because two sides are marked as congruent. So because these two sides are marked as congruent, the angles across from them must also be congruent, which means that this angle is 72 degrees. Now we can figure out angle X because X plus 72 plus 72 is going to equal 180, or X plus 144 equals 180, which means that X equals 36. All right, and then this triangle on the right side is isosceles. We know it's isosceles because two sides are marked as congruent. And the angles across from those sides are this X right here and this one that's empty over here. So because both of those are congruent, they could both be labeled as X. So in this case, the 130-degree vertex angle plus the two base angles, which are both X, are going to add up to 180 degrees. So if 2X equals 50 degrees, as I'm solving this, that means each X is going to be 25 degrees. Let's do one more example together. This one's a little trickier to sort out because nothing is marked as isosceles or equilateral to start. So let's label what we know. We don't know anything about sides of triangles without knowing whether the triangles are isosceles or equilateral. But we do know that all triangles, the angles of the triangles add up to 180 degrees. So we can use that information first to find this top angle over here. Because we know the other two angles in that triangle are 59 degrees and 90 degrees, which would make this angle 31 degrees, so that they add up to 180. I also know that next to this 59 degrees, because it makes a linear pair with the one right next to it, this angle right here is 121 degrees, because 121 plus 59 equals 180. So because that's a linear pair, we can label that angle also. And now knowing the 121 degrees, we can find x. So we would take 180 minus the 121 plus 45. So let's see, 121 plus 45 is 166. So up here we have x is 14. And this is the information that we need to find y. Now here's where it starts looking a little confusing. So I'm going to redraw this triangle without the dividing line in the middle. So if I'm just drawing the big right triangle, so I'm not splitting it up into the two separate ones. In the big right triangle, this angle is 45 degrees. And this angle up here is 45 degrees. It's the 14 degrees plus the 31 degrees. So this big right triangle is isosceles because the base angles are congruent. They're both 45, which means two sides are congruent. So this side was labeled as 4y minus 3. But the side that's horizontal has a 10 and a 2y plus 1. So I'm going to add those those two pieces together to get the whole side. And we know that these are equal to each other because we have an isosceles triangle. So I'm going to set the 2y plus 11 equal to the 4y minus 3. And so I get 14 equals 2y, which means y is equal to 7. So that's how we apply what we know about isosceles triangles and equilateral triangles.